All right, we have another example of balancing redox reactions. So let's go ahead again and go through the four-step process and work through this one. So again, step one is divide into half reactions. So my first half reaction is CN minus makes CNO minus. I'm just getting rid of the one just to make it simpler. And then my second half reaction is MnO4 minus yields MnO2. All right, so first step after that is to balance each half reaction by balancing elements that are not O or H. If you notice 1C, 1C, 1N, 1N, that's good. 1Mn, 1Mn, we're good there, so we don't have to do that. Second step, we're going to balance oxygens by adding H2O. So top reaction, I have 0 oxygens on the left and 1 on the right. So I need to add oxygens on the left by adding a whole water. On the bottom reaction, I have 4 oxygens on the left and 2 on the right, so I actually need to add 2 waters to that second reaction so that I have the same number of oxygens. Next step, we're going to balance our hydrogens by adding H+. So top reaction, right now I have 2 hydrogens on the left and I don't have any on the right, so I need hydrogens on the right to balance that out, and I need 2 of them, so I had 2 H+. Bottom reaction, no hydrogens on the left, and on the right hand side I have 4. Make sure we distribute that. 2 times 2 is 4. So we're going to go ahead and add 4 hydrogens on the left. All right, so we've done that. Next step, I think this is again the hardest step of all of them, is to balance charges by adding electrons. So again, I'm going to go ahead and take a very thin point here, and we are going to go ahead and figure out our charges. So on the left hand side of this top reaction, I have a total charge of -1. On the right-hand side, let's take a look at this reaction. I have 2 positives and 1 negative, so my total charge is +1 here. If I want to make those equal to each other, I actually need to add 2 electrons to this first, to the right-hand side of the first reaction. If I do that, this charge will become -1, and they'll be equal to each other. All right, let's take a look at the bottom reaction. All right, on the left-hand side, I have 4 positives and 1 negative, so my total charge is +3. On the right-hand side, you're going to notice I don't have any charges at all. So my charge over here is 0. So where do I need to add electrons? The side that has the higher charge. So I need to add this over here, and I'm going to add 3 electrons. All right, now this is a case where the next step is going to be a little interesting. We balanced our charges by adding electrons. Now we have to multiply to equalize electrons. Sometimes we just have to balance by a whole number, 1, 2, 3, and just one reaction. In this case, we actually have to multiply both reactions by a number. We have 2 electrons in the top, 3 in the bottom. So we're going to multiply them by each other to get 6. So this top reaction, I'm going to multiply by 3. That'll give me 6 electrons. And the bottom reaction, I'm actually going to multiply by 2. Now, some people at this point like to just kind of do it in their head. I prefer to write it out. So I'm going to distribute this 3 to everything up here. So a 3, a 3, a 3. 2 times 3 is 6, and a 6. And in the bottom reaction, again, this is going to be a 6. 2 times 4 is 8. A 2, a 2, and a 4. And I'm going to go ahead and rewrite those reactions again. So the top reaction, 3H2O plus 3Cn minus yields 3CNO minus plus 6H plus 6 electrons. And then my second reaction becomes 6 electrons plus 8H plus 2 MnO4 minus yields 2 MnO2 plus 4 H2O. All right, now once I've done that, I've multiplied to equalize the electrons, I'm going to go ahead and simplify and add the half reactions together. Again, my favorite thing to do right away here is to cross out the electrons because they are gone, so my electrons are gone. And now I'm going to look for common chemicals, and usually they're going to be H2Os and H pluses. So I have 3 waters here and 4 here. So one's on the left, one set's on the right, so they are going to simplify. All 3 of these are going to go away. We have 4 here, so there's going to be 1 left. Now we're going to look at the H pluses. I have 6 H pluses on the right here, 8 here. Again, that can be simplified. These are all going to go away. And since I had 8 here, 2 are going to be left. Once I've done that, I've got my overall reaction that I can write. Now, I don't want you to leave it like this. We're going to write it nicely. So what's left on the left-hand side is 3Cn minus plus 2 MnO4 minus plus my 2 H pluses yields my 3 CNO minus plus 2 MnO2 plus my 1 water. And that is our finalized redox balancing for a reaction.